students, welcome to my channel. In this class, I am going to solve one more problem on mathematical induction. The problem is use mathematical induction to prove that 1 plus 2 plus 2 square plus dot 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 plus 2 to the power n is equal to 2 to the power n plus 1 minus 1 where n is a natural number. So let us take the entire statement as a Pn. That means Pn stands for 1 plus 2 square up to 2 to the power n is equal to 2 to the power n plus 1 minus 1. Now first step. For n is equal to 1. Left hand side, this is important. We have to take two terms because when n we have taken Pn, this is 2 to the power n, and so there are n plus 1 terms. This is 2 to the power 0, this is 2 to the power 1, so it will be 3. And now right hand side is equal to 2 to the power 1 plus 1 minus 1. This is 2 square minus 1, 4 minus 1 is equal to 3. Implies P of n is true for n is equal to 1. So P of n is true for n is equal to 1. Now second step. Let P of k be true, then we have P of k stands for 1 plus 2 plus 2 square plus dot dot plus 2 to the power k is equal to 2 to the power k plus 1 minus 1, where k belongs to n. So, in the second step, we have taken P of k is true. So, that is why we have written P of k stands for 1 plus 2 square up to 2 to the power k is equal to 2 to the power k plus 1 minus 1. Now, third step. In this step, we have to prove pk plus 1 is true when P of k is true. That is to show pk plus 1 stands for 1 plus 2 square plus 2 to the power k plus 2 to the power k plus 1 is equal to, we have to show that this is 2 to the power k plus 1 minus 1. That is, we have to show 2 to the power k plus 2 minus 1. Now, in this third step, we have to prove pk plus 1 is true whenever pk is true. Now, pk plus 1. This is equals to 1 plus 2 square plus dot 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 plus 2 to the power k plus 2 to the power k plus 1. So, now pk is true, means 1 plus 2 square up to 2 to the power k is equal to 2 to the power k plus 1 minus 1. So, this stands for this. This is equals to 2 to the power k plus 1 minus 1. The last term is 2 to the power k plus 1. So this is equals to 2 into 2 to the power k plus 1 minus 1. This is 2 to the power k plus 2 minus 1. Implies p of a k plus 1 is 2. So in the third step, we have established p of a k plus 1 is true whenever pk is true. Now, fourth step. Here, p of 1 is true, p of k plus 1 is also true. So p of n is true for all n by principle of a mathematical induction. So here the question is to prove 1 plus 2 plus 2 square up to 2 to the power n is equal to 2 to the power n plus 1 minus 1. In the first step, we have taken n is equal to 1 and we have shown here left hand side is equal to right hand side. That means p of 1 is true. So in the second step, we assume pk is true, and that is why we have written p of k stands for 1 plus 2 plus 2 square up to 2 to the power k is 2 to the power k plus 1 minus 1. In the third step, to prove pk plus 1 is true when pk is true. Now pk plus 1 is equal to 2 to the power k plus 2 minus 1, that we have to show. We have started with pk plus 1. It stands for 1 plus 2 plus 2 square up to 2 to the power k plus 2 to the power k plus 1. But the expression starting from 1 to 2 to the power k is equal to 2 to the power k plus 1 minus 1, that I have written here. And this is the last term. So 2 to the power k plus 1 plus 2 to the power k plus 1 is 2 into 2 to the power k plus 1 minus 1. So 2 to the power k plus 2 minus 1. So p of k plus 1 is true. So fourth step, here p of 1 is true, pk plus 1 is also true. So p of n is true for all n by principle of mathematical induction. With this, the topic for today class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.